Okay, so we last week in the homework had a couple of problems that addressed ratios and proportional reasoning. In the elementary school, students are going to be exposed to that in a few ways. One of the most common ratios they work with is, of course, the fraction, which is a part to whole ratio. We'll also see some part to parts in these examples. But had several of you send emails with questions about the homework problem where you had to work with the ratio table. So I wanted to throw up a couple examples like this. Again, these are all possibilities you may have to explain on your final or work through that kind of thinking. So let's take a look here and see what we can work through for these types of problems. Okay, so we're traveling at a constant speed. A race car goes 15 miles every 6 minutes. We want to use simple logical reasoning supported by a double number line to help you determine the answers to the following questions. We're not going to set up equations. We're not going to do cross multiply. We're also not going to calculate how many miles per minute and multiply. We're not going to make it about a procedure. We're going to model it. And we're going to do that with using a double number line in this case. So my first line here is going to be about distance. Okay. So in my first interval here, I've gone 15 miles. So if my first line is going to be about distance, then this one, of course, has to be about time. So if I traveled 15 miles, then I know that this same interval had to relate to 6 minutes. Okay. So 6 minutes have passed. I'm going to have another 6-minute interval. I must also have another 15 miles. So at this time, 12 minutes have passed. Now, honestly, I don't need another 6-minute interval because that would put me up to 18 minutes, and that's too much. I only need another 3 minutes. Now, the question we've got to come up with here is how much is that going to relate to in distance? So if we can't set up an equation, we can't cross multiply, we can't do any of those things, how can we figure it out? Okay. If I think of the fact that I need 3 more minutes, how does that compare to the interval that I've already drawn? Okay. Each of these were 6 minutes. This one needs to be 3, and it's half the size of that one. If that's half the amount of time, it should also relate to half the amount of distance. So if we take 15, we have half of that, 7.5. Okay, so in a total here of 15 minutes, I've traveled 15 plus 15 plus 7.5, which is going to be 37 and a half miles. Okay, so there's my double number line. Okay, I'm using a number line to represent each one of the concepts I'm looking at. Notice that I'm matching them up. Whenever and again, I know my drawing is not perfect, but what I'm trying to make clear here is that for every 15 minutes I cover in distance, 6 minutes has gone by. Okay, so we want to do the same thing down here to think about how long does it take to go 20 miles. So up here, we were looking for distance. Down here, we're going to be looking for time, but we're still going to be using those two ideas for number lines. So I'm going to draw my line here for distance and another one here for time. Okay, so we want to go, how long does it take to go 20 miles? All right, so I know, starting off, that I can work in 15-minute interval, or I'm sorry, 15-mile intervals. So 15 miles, of course, is going to take me 6 minutes. So far, I've got my car, drove it, I went 15 miles, it took 6 minutes. I know that much from the problem. So here's the thing. I don't want to go another 15. I only want to go another 5 miles. Okay. Now, again, just like above, what we have to kind of figure out, what we're looking for here, is how much time is going to relate to that 5 miles. If I look up here, 5 miles is 1/3 of the previous interval in terms of how it relates. 5 is 1/3 of 15. If it's only 1/3 of the distance, of course, that means I should also think about being 1/3 of the time. If you are wanting to kind of show students that, okay, think of this as being your little interval up close here. Okay, that would be your total 15 miles. every 5 of that is a third of that overall interval. So that must also be the same down here for time. If that's 15 miles, then this has to be 6 minutes. And breaking 15 down into 5s would be like breaking 6 down into 2s, okay, because we have thirds of that. So we have 6 minutes plus 2 minutes equals 8 minutes for that, okay? So let's keep tracking here. This one gives us a part-to-part ratio, okay, Quint's CD to Chris's CDs. So we have a 7-to-3 ratio. Some of you may be used to seeing it written like that. And we know that after Quint gave 6 CDs to Chris, they had an equal number. How many CDs did Chris have at first? You solve this using a strip diagram. Now, what we know about ratios, whether they're part to whole or part to part, we know that just like fractions, they can be simplified. So this doesn't necessarily mean that Quint had 7 and Chris had 3. What it means is that it could be some sort of simplified ratio or a simplified fraction if we think about it, for Quint and Chris. But we know for every 7 CDs that Quint had, Chris would get 3. Okay. Now we know, whether that happened once or whether that happened twice or whether it happened 3 times, we don't know, but we know this is the relationship between their two quantities. Now, what we do know is after Quint gave 6 to Chris, they had an equal number. Okay. So a strip diagram, of course, is just that. It's a strip, kind of like a fraction bar in a way. So this is going to be Quint's. And we have 7 parts there. 1, 4, 5, 6, 7. Okay, so it's my 7 parts. And then we have Chris, who, notice I'm trying to keep that as even as possible so that that's something we could see has 3 parts. All right, so let's think about it. If they really did have 7 CDs and 3, think about what would happen if I took 6 away, okay, and I gave 6 here. Would they have an equal number? Right? No. So that's not true. So we know that their actual counts are not the 7 and 3. We know that their actual count are counts that have simplified to a ratio of 7 and 3. Okay, so what other counts could simplify to a ratio of 7 and 3? Okay, could we also have 14 and 6? Would that be able to simplify to a ratio of 7 and 3? Sure it would. And it's actually very easy to draw the strip of that because we just take the strips we have and we cut them in half. And that doubles everyone, 14 to 6. Okay, so let's think about it. If I took 6 away here, I've got 8. And I added 6 here, I've got 12. So does that work? Nope. And that's not going to work. So what is another ratio? Continue to go on that would simplify to 7 and 3. Okay. What about 21 and 9? Okay. If that were the case, let's take a look and let's see here. I'm not going to try to draw the strip out with 21, but I'm just going to kind of write it in here. We'll put 21 and 9. Okay, so let's try it now. If I took 6 away, Quint would have 15. And if I gave those 6 to Chris, he would have 15. So that's their actual count. Okay, if you're having kind of a hard time visualizing this, I mean, you can think of it as a fraction. It's not exactly a fraction here. We're dealing with part to part. But if you were to simplify that, you would be looking at the same concept here. Here we have the most simplest form, doubled it, tripled it, so forth. Okay, so we're continuing to actually make sense of the situation until we find the solution that works. And that is a standard for mathematical practice. Make sense of problems and persevere in solving them. You're doing that very well here. Okay, we're trying to draw out a model, some sort of real life model of what's going on in this problem. And a strip diagram just does that in a linear fashion. Okay. So, last one here, we have in a terrarium, the ratio of grasshoppers to crickets is 6-5. Okay, so it's grasshoppers to crickets. Does that mean that there's 6 grasshoppers and 5 crickets? No. It means that no matter how we compare that ratio, it can always simplify to 6-5. It could be 6-5, just doesn't have to be. Okay. And in fact, when we read on to the next line, it tells us specifically we know they're not. We know there actually are 48 grasshoppers. So what we want to know is how many crickets there are, and we want to do that with the aid of the ratio table. Again, we are absolutely not going to set up equations and cross multiply, guys. That's not appropriate for elementary school. This is an elementary math course, okay? So it's not appropriate to use those methods. Not to mention, even if you're using them with some of your older students and they don't have any idea why you're setting up those equations like that, what you're doing is putting a Band-Aid on a stab wound, okay? You have to get them to make sense of what they're doing. And a ratio table is going to do that. So let's look here at our ratio table. Basically, this ratio table is just going to help me draw out the possibilities between the counts of grasshoppers and crickets. Okay, so I know I can start out with 6-5. Now, some of your younger students or those who maybe have not come up with efficient means of going through calculations like this might just continue to double and triple and so forth. Okay, here's what I mean by that. Okay, now if we do that, does this 48 to 40, does that simplify to a 6-5? Okay, absolutely. We have 8 times the ratio there. Now, this is a very inefficient way of doing it, but it does work. Students may do this differently. In fact, when I did this problem originally, I went to 12 and 10, and then I went to 24 and 20, okay? And then I went to 48 and 40. So instead of doubling, tripling, so forth, doubled, quadrupled, and then times 8. So I just condensed that, but it's a possibility that it works either way. Okay, so this is what a ratio table looks like. It doesn't have to be anything fancy. It can be horizontal, it can be vertical, but it's going to keep track of 2 quantities and how they relate to each other, and it's going to preserve the relationship every time we make a new step or every time we make a new entry in this. Okay. Now, what do we mean by preserve the relationship? No matter how many entries I have in this ratio table, each one of those ratios is going to be a ratio that could simplify back to 6-5.